All right. Well, 12:30. I think that means it's time to get started. So thank you for coming, everyone. My name is Jimmy Bogard. You can find me on Twitter at @jbogard. You can also find me on GitHub at github.com/jbogard. And so this presentation is in a repository there. There's a presentations repository. So this and every other talk I give is on my GitHub there. And I blog about this topic and other things, I guess, on my blog at jimmybogard.com. I'm an independent consultant and also chief architect at Headspring, a consulting company. And so my day job is building systems using all the things we'll be talking about today. I do a lot of open source work, which is basically taking the tools that I build during my day job and then trying to use them in the next project. And so some of the ones over there, Automap or Mediator, those are the big ones people probably know. And I've gotten an MVP award for I don't know how many years. I used to not have gray hair before I got the MVP award, and now I do. So take that as you will. So yeah, today I wanted to talk about microservice communication and conversation patterns. And I do quite a lot of work these days with microservices and with distributed systems in general. And one of the things I often find when people are having trouble both designing and kind of mentally picturing how these systems work together is they don't have a lot of the correct or effective pattern languages for being able to put these systems together in an effective way. And so for the bulk of my career, or the early part of my career, it's not the bulk anymore, most of the systems I work with were just kind of your standard in-tier style architectures. So it's like, I'm building a web app, okay? And the web app has to talk to a database. And so the things I needed to worry about were basically, I got the user interface, I've got the guts in the middle, the business logic, and then there's the database at the end. But that was mainly what I worked with. It's just these kind of everything's in one single application. But as I started to move further out from that architecture into different kinds of systems, I started having to deal with not just one application all on its own, but now I have to worry about how this application talks with other systems and other applications. And as more and more folks started to go down this route of trying to build smaller systems, a movement arose around this idea that it's okay to build individual systems and services that stand alone, and then they can use communication to talk to other services, and then coordination to be able to build a coherent experience for the end user. So before we get too far down the road, I want to first define what we mean by microservice. Because it's a bit of an overloaded term these days, and like anything else, like the vendors will take a hold of it and then redefine it to sell something that they want to sell to you. So I want to try to find something that made sense to me, because in the original book, the Sam Newman book, the Microservices book, it describes microservices as a service that is small and does one thing well. And that's a lot of subjectivity in that, right? It's small. Okay, so what does that mean? Is that number of lines of code, number of features, amount of functionality? Like what is small? And after that book was written, I saw a number of surveys of the industry of like, how big is your microservice? And there was something like 5 or 6 orders of magnitude between the relative sizes of what people called their microservice. Everything from 100,000 lines of code to 10 lines of code. And so what is the truth of what small is? I mean, it just basically means you can't use size as that measure. So small and does one thing and does it well. So how do you quantify those 3 things? Small, one thing, and well. Is it just when you see it? I don't know. So I didn't like that term. It didn't really make a lot of sense to me. But I tried to key on the word service, and it turns out the word service does have some definition in the broader development ecosystem. And so I tried to say, okay, well, microservices are really a service-oriented architecture. Clicker. There you go. It's a service-oriented architecture in which we have a design focus towards the smallest, still autonomous boundary. And the key word there is being autonomous, because if it's not autonomous, then it is no longer a service. It's a function or just a procedure or a database table. Autonomy for a service means it lives and owns its own everything, really. It owns its own functionality. It owns its own data. It owns the way it communicates with to the outside world. It's in charge of its own security. So it's in charge of all the stuff it needs to be able to run. Now that doesn't mean it's completely independent. It doesn't run just in this box over here and no one ever talks to it. But there's a level of standaloneness that it has to ensure that it's in charge of everything it needs in order to fulfill some kind of business functionality to the end user. So that's for me what microservices are. It's taking the well-defined service-oriented architecture principles and saying, what we're trying to do is make those boundaries as small as we can while still fulfilling all of the goals that a service-oriented architecture strives for. And it's not technical, so it's not containers or Kubernetes. It's not different kinds of clouds. It's not different ways of deploying. So you can do microservices with deploying things in virtual machines if you want to. There's no technical constraint on this, just like there's no technical constraint on services. So with this in mind, as I started to build systems like this, I try to figure out what is the right way we should think about and design these kinds of systems. And what I often found was when folks got in trouble building distributed systems and microservice-based architectures, a lot of times what they would build would never work were not that these things were so small. And what I try to do is look at that and say, okay, there's a level of autonomy we want to achieve with these services. And if I look to past history and past art, prior art, of what it means to be autonomous and doing your own thing, I often found that in the real world, we have the very similar sort of problems that we see in distributed systems. So if you imagine a human being as an individual actor, an individual service, they have a level of autonomy as well. I can do my own thing. I can decide for myself what I want, how to do things during the day. But I still operate under certain guidelines, and I still have to interact with other people, although I guess less in the COVID days. And so in my head, I thought if I can design systems that could work in the real world, then those systems have a much higher chance to succeed in the virtual world. Because in the virtual world, although a lot of the constraints are lower, they're never eliminated. There's always going to be communication delays. There's always going to be communication failures. There's always going to be system failures, just like there are in the real life. So if the thing I'm trying to build will work in the real life, then it has a much higher chance of working in the virtual world. So what I like to do is look at some real world systems that operate under some of these same kinds of constraints and explore how we might use messaging, how we might use conversation patterns, and how we might use coordination patterns to be able to scale these single standalone businesses to global reach and take over the world. So let's look at some businesses that operate in the real world and how those translate into the virtual world, and how those different businesses may scale. And so the kinds of businesses that you've seen scaled over the years have done so under the same kinds of constraints we see virtual systems scale as well. So things like mail order catalogs, we don't have these things today, but they used to be a very big thing where you'd have these catalogs that were printed out and mailed to millions of people, that people would order things in them, and then sometime in the future they'd be able to receive their order in the mail. So that's very much like a website in which we have a kind of single view of everything the customer needs to know in order to order something. And at some point, there's an order form where they fill out and they go submit the information, and then someone goes ahead and fulfills it in the back end. If we talk about scale, you really don't have to look any further than like fast food restaurants. In fast food restaurants, they've been able to take what was like one shop in one location and scale those globally. And the story behind these is actually very well documented. So if you've seen the movies and documentaries about McDonald's, for example, it's fascinating to see how they take something that worked really well in one spot and were able to take that and scale it out worldwide. So I live in Austin, Texas, and in my office that I used to go to, one of the things we'd have every day is a food truck. Food trucks used to be not so hipster, but like everything else, the hipsters appropriated it, and now like food trucks are everywhere. They have these like awesome fusion foods, whatnot. And so the office we had that I used to go to had a food truck that would come every day for lunch, and every day there was a different food truck. And the food truck that I really enjoyed going to, one that did hot dogs. It wasn't just any kind of hot dogs. These hot dogs were deep fried, but but not just deep fried, they were wrapped in bacon and then deep fried. They're just absolutely delicious. And then they do kind of a play on the different recipes for hot dogs. So you could use like a plain hot dog with mustard, ketchup, whatever. But they do interesting ones. So one of my favorites there was the hot dog with kimchi on it. So it's a Korean style hot dog, and they called it the Kim Dog Il. So a little play on words there because they have to be clever. But what was interesting about this is this food truck was run by one single person. And when I looked at that operation, it reminded me very much of the kinds of systems that I used to build, those one applications that do everything. So in this food truck, I've got the owner and the proprietor, and he does every single step of the ordering process. So they take the order, they make the order, and they give the order to you. So everything is done by one single person, everything is synchronous, and everything is in process. So in synchronous, what I mean by that is like when I go up to the counter of the hot dog food cart, and they take my order, I don't leave that spot until I get my hot dog and the rest of my order, and then I leave. So during that time, the entire operation is blocked and nothing else can happen while my order is being processed. So this sounds very familiar, right? This is like your standard NT architecture. You have the user interface that you show to the end user. This is like your interaction to the outside world. And then they take that request, this very well-defined structure about how they take information. They go behind the scenes, they go make the order, then they come back and then give you the result. So you don't necessarily see all the stuff behind the scenes, but everything is synchronous. Everything is done by like one blocked request thread. I mean, async await, I guess that does some things too. But it is for the end user, they're sitting and waiting on that screen until the request is fulfilled and they receive the response, and then they can go on and do the next thing. So now, if I'm someone that wants to start my own business and start my own food truck, then what I really want to care about is like maximizing the number of orders and the dollars I can make in a single hour. And so the same thing with our websites. Like we want to make sure we have very high throughput, very low latency, because the higher the latency, the lower the throughput, then the more people hate our slow website and go on and do something else. So the similar thing we have to look at for our food truck. So what we can do is take each step in the ordering process and just break it down. How long does it take each step to work? And in fact, you've probably done this on your slow website using a tracing tool to figure out where your bottlenecks are. So looking here, we can see that, by the way, I completely made up these numbers. Taking order could take 30 seconds. Dressing things out, like putting things on the little thing, takes 10 seconds. Grilling things takes 100 seconds. And then packing it up takes another 10 seconds. And finally, if I add all those up, it tells me that it takes about 2.5 minutes for each order to get processed. So that means the maximum number of orders per hour is 24. I did all this math ahead of time because I always get it wrong. So 24, yes. Okay, so that means as a business owner, I could say, well, what's the dollar amount per order on average? What's the number of time it takes per order on average? And then multiply that out times the number of hours I expect to be in business for any given day. And then I can have like a theoretical max of the amount of revenue I can make. And then I can balance that exist. Well, what are my operating costs, and determine if this model is profitable. So we look at this and say, maximum orders an hour, 24. So great, ship it, get out the door, get the food truck, get all the appropriate regulatory requirements done, and park somewhere and start taking orders. Now, I, as an owner, if I put this in place, what I would notice is I would never get close to that maximum number of orders per hour. And that's because we have some further complications to this overall model beyond just this kind of simple math that we see here. So some of the complications we have are, one, people don't like to wait in line. Because all the requests are stacked up in a single queue, I coming in, the amount of time to take my order isn't just the time that I'm waiting at the counter. It's my time in the line waiting for everyone else in front of me to be done as well. And when people see a long line, they just walk away. Like if I'm going out there for lunch and I see a lot of people waiting for a hot dog, like I'm not going to wait 30 minutes for a hot dog because they're good, but they're not that good. I can order Jimmy John's, whatever. They have it to me quickly. And the reason why that line is long is because we cannot assume a constant rate of flow. So even though one order may take 2.5 minutes, we can't assume that we're going to have one order per 2.5 minutes, that people come out like lemmings, dropping down like bloop, bloop, Bloop. That's just not how it works in the real world. In the real world, what happens is there's peaks and valleys at certain points of the day. Like we're creatures of strange habit. I don't eat lunch at 12:07. I eat lunch at 12 or 11:30 or 1:30 or 1, like at these very specific times of the hour. And they also come in groups, right? I'm going to go down for a hot dog. I put a message up on Slack and say, hey, I'm going to go down for a food truck. Who wants to come? And so like a group of 5 of us will go down. Even though that's not the most efficient use of our time, like no one wants to wait around by themselves on the phone, just looking at the phone in the heat. We'll talk to each other, whatever. So even though we say like, we have a theoretical maximum of so many per hour, that does not imply that's going to be the constant rate of flow of people coming into this equation. And the person that comes in that sees this long line is just like, what the hell's going on here? It's a long line. Why are things so slow? And then they'll just like, go do something else. The person that's, this has got to be a horrible feeling. The person that's the owner of this food truck, they see that person walking down like, oh, great, more money for me. But they see that person look at the line, get upset, and then keep walking. And so the person that's, owning the food truck, they just see money walking out the door, walking away. So we need to fix this, right? We need to get more efficient with our operations and try to scale this operation up. Now, one way we could do this would be just to say, let's just scale up. So we'll just have a bigger food truck, like two food trucks, scale it up. But that's not what happens in the real life, right? You don't go out to see a food truck and see 2 identical food trucks sitting next to each other, because there's a lot of overhead for each of those food trucks to be able to get all the kitted out, get all the regulations and stuff like that, all the requirements there. That's just way too much work and way too much upfront capital cost to do so. So that's not what people do. Instead, what they do is they divide and conquer. They say, how about instead of one person doing every single job, how about we hire more people and we divide the responsibilities of each step in the process between those different workers. So in this picture, everyone does one single job. That means though that by one person doing one specific job, that means they can optimize that job by itself. So the grill person, for example, is like, I don't need to cook 1 hot dog at a time. Why don't I cook like 6 hot dogs at a time? If I see a group of 6 people walking towards me, why don't I immediately drop 6 in the fryer and get that order going so that it's ready for them by the time they get there? So each individual step can now self-optimize and scale individually how they work and how they need to work in order to be able to handle more orders at the same time. So at this point, ordering is really the only true bottleneck that we have now. And now the amount of orders that I can successfully take per hour, because here what I'm measuring is like the amount of money I'm getting in. The maximum number of orders per hour and the number of orders that I can take is now just the time to take an order. And I think we said that takes 10 seconds, which I just made that up. So now instead of me having 24 orders per hour is my theoretical max, now it goes all the way up to 120. So it's almost an order of magnitude more orders per hour by just saying the only constraint, the only bottleneck in our system now is going to be just one individual step of the synchronous order taking from the customer. By the way, all these numbers are completely made up. I did actually work in fast food in high school, so I know there are further complications. But with this kind of simplistic view, you can kind of see like now if I make each person do one specific job, one domain of responsibility, then they can optimize that individual step without worrying about affecting anyone else. Now it's easier said than done, right? Just take the 1 circle and make it 4 circles, profit, right? Well, not so fast, because how do we actually fulfill an order now? In our previous picture, where it was just a synchronous request response, like one person coming in, placing an order, everything happens. There was no coordination or conversations or any kind of management that needed to happen. The one person did all the steps in the job, and that was easy. Like just do all the things and be done with it. But now our picture is more complicated, right? The transaction, the business transaction is no longer synchronous. I, as a customer, don't sit at the window until my order is done. I only tell them my order, and then something happens in the background that's not visible to me whatsoever. So we have to worry about, like, how do later steps know what to do? How do we know when we're done with an order? And the solution to all these is going to be communication with messaging. So I want to take each of these interactions one by one and explore what are the different ways we can achieve this overall goal based on the different messaging options that are available to us. So let's look at the first interaction, placing an order. So what do I need from the customer? I need to know what food you want. What is the information you want to order? I also need to know how to notify the customer that that order is ready. So we'll come back to that in a little bit. And so typically what you'll see here is that this interaction is a synchronous blocking interaction. So the cashier and the customer are not doing anything else while this interaction is occurring. It's not like I write down my order and put it on a piece of paper and then slide it over the counter to the person that is taking the order and walk away and not check to see if they've actually received the order. No, it's a synchronous interaction. You're talking to the other human, and both sides are blocked and unavailable for any other work while this interaction is occurring. It's also a non-durable communication. That is, no one writes it down. The order is requested verbally. So I say my order to the other person, and they have to be paying attention for them to receive the order and take it. But because this person is dedicated to doing that one job, it's a very high likelihood of success. So in the virtual world, what does this look like? What is a synchronous, non-durable interaction? Well, we'd probably pick some kind of web interaction. So in this case, I've got HTTP, which is a synchronous interaction between a sender and receiver. The sender will post up their information, and the receiver will give an immediate response, or give a response back to the originator, the information about the order. So here's my order information, and they come back and say, yep, we got it, and here is some information about your order. So what kind of patterns are we using here? This is a synchronous request response. I am synchronously requesting some work to be done or some information, and I'm waiting for a response back. Now, even though we may have things like async await going on here, the receiver is still waiting for the response before it can do anything else. So even though I call it synchronous, we may have async await. Async await is just about like putting threads to sleep to do other work, but the flow of execution is still waiting for that response before it can go on to the next line of code. The same thing with my person here. It's like I'm waiting for that response back before I go and do anything else. Okay, so that was the easy part, right? Just, okay, yeah, we'll just take your order with a website, web page, done. What about all these other steps? Should we use durable or non-durable messages? Who is managing the flow of information between these steps? And if something goes wrong, how do we manage those failures? So the first interaction, I got to tell the people in the back what was ordered so they make the right thing. Now, what if we did a synchronous request response? So I take the order, and then I turn around and immediately call to the person in the back to say, okay, order up. This is what they ordered. That could work if that person is listening. But what happens if I don't get a response? Like I say, I got an order for you, and I don't hear anything back. And what's really going on is like, I'm busy. Like they're busy actually doing the work. They don't have time. Like, I got your order. Geez, leave me alone. And so we might get a response of like, service unavailable. I'm trying to do the thing, but it never came back to me. So I don't know what's going on. So something's unavailable here. So what happens in real life? I yell again. Hey, order up. Do the thing again. And so the person sending them the request will have to repeat themselves. Like, you didn't hear me the first time, so I'm going to repeat my request again. And then this time, I might get a response back from the person doing the work. So this all works okay if that person actually never received the first request. So we have to worry about, like, if I tell them to place an order and they actually heard me the first time, but they were too busy to give me a response, and I tell them to tell them the order again, are they going to make 2 orders or are they going to make 1 order? And so the question becomes, like, was that the same order or was that a different order? Well, we can also have a different way of doing it, of saying, instead of them doing the work immediately, when I tell them, hey, there's an order ready to go, what if it's kind of a fire and forget? So instead of having them do the work immediately, what if they just take the information and they just tell me, yep, I got it. and they're writing it down themselves. So I yell it to something, they say, oh, I got it, I'm gonna write it down, but I'm doing the work later. So I just say, yep, I accepted your order, but we'll do it sometime in the future. That does put a lot of burden on that person listening to be able to write everything down as they go. So that may or may not be what we're looking for here. Now, if I look in kind of simple restaurants, this flow is actually pretty common. So restaurants like Subway work in this exact sort of manner, is that they kind of have one step that goes and then just goes through the process one by one. So the way the order flow works in real life is just a single kind of step-by-step set of actions. It goes to the first step, then it goes to the second step, then it goes to the third step. And there's no real deviation between these different steps. We actually got a burger joint here in Austin called Mighty Fine that works exactly like this. So the way they work is when you go to place an order, the person in the order counter takes this bag that you see in the picture here. They write your name on it. And on that bag is the possibilities for what you can order. And it's a very simple menu. It's like literally burgers, fries, and a hot dog. That's it. So it's very well known ahead of time what are the different possibilities for a way an order can flow through the system. And so what they'll do is they'll circle the things that you've ordered on there. So like, okay, we've got, here are the toppings you want in your burger, here's the drink you want, and do you want French fries or not? So that's a little FF, that's the French fries circled there. And so at the point you take your order, it's predetermined what are the different stations that order needs to go through in order to fulfill it. So if you didn't circle French fries, you don't have to go to that step, and it can go straight from burger to the delivery station. And so this kind of pattern in which I, from the beginning, know the exact order of steps that the request needs to go through in order to fulfill this overall business process is known as a routing slip. A routing slip is an asynchronous message. That is, I write the information down on something, and I pass that information from step to step to step. And as each step does its work, it doesn't decide for itself, like, where do we think I should send this next? Instead, it looks at the routing slip, which is just a list of steps that describe these are the different destinations that this message should be sent to. So in the case of my Mighty Fine Burger, the steps are on there, right? It's like if you order French fries, it doesn't go to the fry place. If you don't order a drink, it doesn't go to the drink place. So based on what you've ordered, that's how everyone decides where the next step should go. Now, the way this would work in the real world is that each step would have its own backlog of work, their own queue of work. The asynchronous durable messages allow us to remove that synchronous activity that we saw earlier. That is, I was yelling out to the dress person, hey, we've got an order, and hopefully they're paying attention. With an asynchronous message, I don't need to care if the next person is paying attention or not. All I need to do is slide the information over to them into their queue, and then I can keep on doing my work. And so this way, the independence of each of the individual steps are maintained. I don't have to worry or care if every step is up and available at all times. I can still do my work without worrying about what's going on behind the scenes. And you'll see this in real life. You'll see order tills where in a diner or something, they'll take an order, they write it down, like in a Waffle House, and then they'll put it on a till. And the till is just a queue of orders that they're maintaining. And as they decide to make an order, they'll pull the order down, look what's on there, make the things up there, and then slide it over to the next step. And then they'll move the next ones down. So in this manner, I don't have to worry about the synchronous communication between all these different steps behind the scenes. Instead, I let the message just flow through the system, and by the end, it'll be able to deliver to the end user or the customer. Okay, so this is a simple way of working. But what if things get more complicated in my restaurant? What if we turn it up to 11, if you will? And let's look to see how larger chains approach this problem. So how do larger fast food restaurants try to solve this problem of maximizing the number of orders they can fulfill in a single hour? So in these restaurants, the big difference is the items are greatly multiplied. So you don't have just 3 things you can choose from. You have a lot of different things you can choose from, and you can customize each individual option. So instead of having just 1 or 2 stations, I have many different stations that I have to worry about. And so in this case, we'll have each station dedicated to a specific activity, but now it's not so simple of just me flowing the order through each station step by step, because in this case, like, many steps are now independent of each other, but some are not. Like, I have to grill the burger before I put toppings on the burger, but I can grill a burger and fry things at the exact same time. Unless it's a sandwich with something fried on it, then I can't. So it's like a complex set of dependencies between each individual step. And so it's not as simple as just saying, let's just use a routing slip, and every order has to go through every single step. Now, McDonald's did start out this way. They were, very simple. They got super optimized on this, like, you only have 5 items in the menu and just go like that. But as its patrons became more sophisticated, or not, then they had to branch out from this very simple set of ordering system, stop like making everything, hours in advance and putting it under a heating lamp, and, like, have things customized to each individual order. And so we can't just do the very simple optimized steps anymore. We have to have a more complicated set of interactions here. So that's our challenge here. How do we manage all this different work going on? Now, I actually worked in fast food, so I can at least relate those experiences of how that worked. It wasn't McDonald's. It was a local chain here called Whataburger. It's fantastic. And it wasn't, it was pretty complicated, the system, to be able to manage all these individual orders. So let's go through each interaction and figure out, well, what's the best way to approach each individual step. Now, taking the order is still going to be a synchronous operation. I'm going to go up to the counter. I'm going to tell the person my order, and they're going to tell me how much it is and confirm the order behind the scenes. Now, these days, technology, there are more complex ways of ordering. Like, you can order online now. You can order in an app. I've even seen, like, kiosks, right? You can go to some fast food restaurants, have like a kiosk, but, like, I don't want to touch those things, so I'll probably still talk to someone to get my order done. But it's a synchronous operation. I'm doing nothing else but providing my order information to something that is synchronously giving me feedback immediately about, am I done with my order and how much the order total is going to be. So regardless, this initial interaction is still going to be a synchronous operation in this picture that we see here. It still doesn't make sense for me to, like, write down my order, send it over in an email, and then they email me back, here's the order total, and then it's a synchronous operation, and it's never going to be made completely asynchronous. But now that I've taken the order, what now? How do we process this behind the scenes? Synchronous is going to be completely untenable, right? You don't see these restaurants with the cashier, like, yelling out to everybody, okay, guys, we got another order coming in. Let's everyone rally around and get everything done, and they're like yelling at everyone to get stuff done. I don't know if you've ever seen, like, Kitchen Nightmares or Gordon Ramsay, whatever. He goes into some of these restaurants where they do try to operate like this, where, like, one person just yelling at everybody to get stuff done. It doesn't scale very well. Everyone gets upset and quits. So making everything synchronous isn't really how the real world works. So it shouldn't be how our systems work either. A routing slip is going to be way too inefficient, because that means I'll have the message going through a bunch of systems and queues that don't need to go through. So if I have someone coming in and ordering 20 burgers, the fire's like, no burger, no burger, no burger, and they're just wasting the time with orders that they don't care about. So the solution here is going to be a conversation pattern. Now, conversation patterns are a higher level of patterns beyond just the normal kind of the single actor messaging patterns that you typically run into. And a conversation pattern involves multiple messages over potentially multiple different services or actors in order to accomplish some kind of business goal. So how does McDonald's do this? Well, the first step is they're notifying the relevant stations that they have an order coming in. And each of these individual stations have their own individual queues. So in this case, I could do something like I'll publish an order created message, and this gives me a link to the order information. Now, when I actually worked in fast food, I had a little computer screen up above me, and when a new order came in, a new order would pop up on my screen in a queue with all the different orders. Now, McDonald's, they need some way to figure out when an order is done. So they have to figure out, how do they track completion? Now, the way McDonald's does this is with a physical memento. memento, yes. So they take that tray, they put it down on the counter, and the physical tray holds all the items relevant to the order. The receipt that's on that tray is not the same receipt that you received as you, the customer. It's a special receipt that just shows the details of that order. So it doesn't have all like the credit card and coupons and junk. It's just like, here are the items in this order. So now we have to worry about, how do we coordinate done? When an individual step is done, how do we know that the order is done and that we should finally deliver this order to the end user? So let's look at habits in each step. So the person making the dressing the burger is done with their step, and so they go to put their items on the tray. They check that receipt for doneness. That is, they check to see if all the items on the receipt are represented with items on the tray. In this case, not everything is done, so they say, nope, we're not done. So they go back to their station and continue on with the next step in the process, or the next order on the screen, that is. Next person, the grill person. They place their item on the tray. They check the items on the receipt for doneness. Nope, not done. They go back to their station and continue on with the next order in their queue. Finally, we've got the fryer doing the French fries. They place their item on the tray. They check the items on the tray against the receipt for doneness. This one they say, yep, I do actually have everything on the tray ready for the order, so it's time to, quote, ship the order to the customer. So this pattern, this conversation pattern, is known as choreography. Now choreography is like, I guess, dancing, where everyone's kind of doing their own individual thing, going around with each other. And in choreography, we have an event-based initiation of this conversation. So in this case, it was order created, and that was notified to all the different stations in parallel. And then as each step comes in, we don't necessarily know what order those steps are going to complete in. So the step order is not going to be enforced. I don't say grill must happen before fryer. I publish it out so that each step can be done in parallel and work on their own time. But we do have to track completion. Because things are not in, like the order of operations isn't enforced, and we're not directing the way this should go, then we have to have some way to know that we're done. So that's the whole point of that receipt. Years ago, I called this the observer pattern because I'm observing a set of events to know when things are completed. But choreography is the microservice communication pattern for this kind of interaction. We didn't solve one problem, though, which was, how do we deliver to the end customer their order? We need to have some way to correlate orders with people. And our synchronous interaction we saw with the food truck earlier, there was no need to have any sort of tracking. When I made something, whose order was it? The person that's still standing there. In this case, though, I don't have any guarantee in the order in which the orders are completed and finalized. So I can't just rely on, okay, I put this tray down first, you go stand in that line over there, and then this tray goes to the first person over there. That's not always going to be the case. So we need to have some way to know, when looking at a tray, whose order is this out there? There's a couple of different ways we can do this. We can use a natural correlation to correlate this set of work with some individual that came in. And so a natural correlation you often see used is someone's name. You see Starbucks does this, right? When you go to Starbucks, you place an order, they ask you your name. I think now they say, whose name should I put down? Because they don't want to presume your name or whatever. Of course, they always misspell it and screw it up. But in any case, they ask you for your name, and they write it down. And then at the end, they call out your name, and that's who gets your order. Now, in that case, with this kind of natural correlation identifier, there can be problems with that. Like, two people can't have the same name. So like at Starbucks, they'll say Jimmy with the mocha whip half soy frappuccino, whatever. And if there's two people with the same name that ordered that same ridiculous item, then whose order is it? And maybe they just give it to the first Jimmy that comes to the window. I don't know. So in order to eliminate the guessing game that happens there, so we can use an artificial correlation identifier. This is what most fast food restaurants do. Like you're not a person to them, you're a number. So they give you a number, and then you take that number. It's either on your receipts or sometimes they have a little placard that you take, and then you go sit down at a table and you wait for your number to be called. Now, which one is better depends on your use case, but we need to have some way of correlating that, that conversation with the final end goal of the customer getting that delivered. And so next time you go to a fast food restaurant, I guess whenever it's safe to do so, you can pay attention and look behind the counter and see like how they're actually performing all this set of work. Sometimes it's not the person that's doing the work that actually delivers the food. Sometimes it's like this rover in the middle that is looking for orders that are done, and they're the ones that are taking the orders to the trays and doing the work. But one thing that you'll also notice is there's a human checking the receipt. So whenever I'm in this case where it's a human checking checking to see if my order is done, I always like peek open the bag and I'm like, is everything in there? Because that's easy to make a mistake on. But this is a code-based system, so we could do a better job of that. Okay, so even in this restaurant, things are more complicated than our simple kind of like Subway food truck set of items and delivery mechanism. But they're still pretty well known about the different steps that occur and how long it takes to do each individual step. What about larger restaurants? So these are things where like the time to complete any one item can vary greatly. So if someone comes in and orders like a 48-ounce porterhouse, well done, it's going to take forever to cook that thing. Versus someone coming in and like, I just want a salad, just a salad. That's easy to get done. So it's not as easy as we saw before of each individual station operating completely independent of each other. We need to have some more coordination, perhaps. So in these cases, the orders are much more complex. They can have multiple different courses for the meal. So I can have drinks, then appetizers, then main course, then desserts, and then aperitif probably at the end as well. And so people, what they're trying to maximize is not the number of orders per hour. They're trying to maximize the dollar per order. And so they actually want you to sit there for a longer period of time ordering a bunch of stuff. That's how they make more money. So for them, like they actually want more complex orders because that means that you're spending more money with them. In this case, the timing matters a lot more. Now, I don't want to have certain things come out and be done much earlier than others. So it takes a bit more upfront planning to make sure, like when I've got a table of 4 people and they order 4 different things, that they all can come out at the same time. And I'll have 3 come out, and one's like, sorry, like your steak's not done. Why don't you wait 10 more minutes and stare at the other people eating, and then you'll be out. So we need to have a lot more control over the process in order to be able to fulfill these orders. And that's where you need like the Gordon Ramsay of the world to be able to explicitly control every single step along the way and decide when everything should actually be done. So in this case, we need someone in the middle that is making all these decisions and really directing the work of when everything should go through and when everything should be done. So in this case, we have this like benevolent quote dictator who is our chef, who is really deciding when things get started, when things are completed, and assembling everything at the end to be able to deliver it to the customer. So in this case, I don't walk up to account anymore, right? I have the waitstaff to come out and receive and get the order. The chef creates that plan of completion in their head sometimes, and then they're barking orders at people at specific points of time to be able to get stuff done. So in this case, I still start off with my order with the waitstaff. My waitstaff now comes to my table to place the order, but it's still a synchronous operation. This time though, I don't get the check immediately, right? I don't get the order total. I'm just getting confirmation they've received all of my items. So I say, here's the items that I want. They write them down, hopefully. And then they say, okay, thank you for your order. It'll be out shortly or whatever they do. So they take that now and take it to the benevolent dictator, the chef. At this point, the chef can decide, do they want to have a written form of communication, or are they going to yell at everyone exactly what they need when? So they could just be like yelling at people. Yeah, okay, I need fries up, need some fries. And they expect an immediate response from the fryer, or they'll yell at to go ahead and drop the fries in the fryer for this order that's coming up. Some things can be delivered more immediately. So, someone wants a beverage with their meal. They don't need to wait for the meal to come to receive the beverage. And in fact, if I give them the beverage now, there's a more likelihood that they will finish it and order another one when their meal comes. So let's go ahead and get that as soon as possible. Okay, so now when the order request is finished, I say, okay, got everything. Now I need to tell the chef, okay, here's all the information for the order. It's ready to be done. Here you go. So at this point, the chef is going to start sending commands to each of the different steps to start performing each step of the process. So I'm going to send a command to the grill person. Hey, I need you to make a burger. Here's the details. Hey, fry person, I need to do some work. Hey, go pour that beer now. I can go ahead and get that out. When items finish, then that chef can decide, okay, this can go out immediately or it can go out sometime later. So when I receive a confirmation that a single step is complete, then the chef can say, okay, go ahead and deliver this pint to the customer. It's ready to go. Now, fries take less time than the burger, so that's why I waited a little bit to have the fryer start those fries. I wanted to get the burger done first, and then the fries later to make sure that they come out at about the same time. So as each step finishes, it notifies the chef this item is complete. They'll still put it up on like a warming tray, whatever, to be able to keep warm for the next step. And as each step completes, the chef is keeping track of what's done, and then finally when it's done, it'll notify the waitstaff, okay, now I need you to deliver this order because everything is done and it's ready to go. So notice in this picture that it's using a lot of commands, a lot of like direct requests to individual steps to be able to perform some action at a specific point in time in order to coordinate these activities and try to have them done together. And so this is known as orchestration. With orchestration, the process is typically started by a single message as opposed to a series of events. And when I start with a single message, then I can explicitly control what subsequent messages go out the door and when. So in this case, I'm typically using commands to coordinate for other steps in the process. I'm telling each step what to do, and then I'm still using asynchronous communication, but using a command to say, make the burger, and then I'm waiting for a response sometime in the future. So this request response pattern is what we're using to indicate completion. Doing each step in the process, getting each completion, and then there's, because I'm directing the flow of all these different steps, there's going to be a lot less tracking of the overall status. So in this case, if I'm in my head keeping, here's all the things that need to happen, then I don't have to necessarily write everything down because I'm the one that's really directing, okay, did step 1, then step 2, then step 3, then step 4. By receiving the completion message for step 3, I know that the next step should be step 4, so I don't have to like keep track of where I am. The fact that I get this message in tells me exactly where I am in the overall process. Now, this is not an either-or picture. Like you're not, when I'm designing systems, I don't say, always use orchestration, never use choreography or backwards. What I really want to look at is what is the work I'm trying to get done, and look at the overall flow of information, and what is the coupling between each step in the process. So look at how each step needs to occur, and look at what steps depend on other steps, and figure out what is the best way to organize those steps so that if I need to change it in the future, I'm not breaking a whole bunch of stuff in the process. Now, what this means in practice, though, is that orchestration is usually something we do inside of service boundaries. The reason why I say inside of a service boundary is because in this picture, our services aren't truly autonomous. They don't really live by themselves. The service here is really just like the restaurant. The overall, like the big orange box at the top, that's the true service. I am making a request to the service and I'm getting information back, but otherwise it's a bit of a black box about how it decides to fulfill those steps behind the scenes. It is really the thing that's like, I'm figuring out how everything needs to fit together, and I'm directing how everything needs to go. And so for that, because the autonomy is really at the kind of chef level, then the service boundary is not each individual station. It is really that overall orange box there. Choreography, though, is something you usually see between service boundaries. So if I can't guarantee the order in which things happen because things are coming in via events, then that's something I would reach for choreography for, because I'm not telling everyone what to do. I'm using notifications and events in order to do so. And you've probably noticed this in your work as well. You've got like the micromanager that is like telling everyone what to do when, and you hate that person because they're making your life hell. Where what you like to do is like, just tell me what you need and when you need to buy, and then I can figure out for myself how to organize my time in order to get that work done. You're usually much happier about that because you have more autonomy to be able to make your own decisions and do the work yourself. So in all of this set of pictures, we've really been focusing on one side of the equation for the kinds of systems that we deal with. And that is like performing business actions, performing business operations. But we're really ignoring the very first step in the process, which is I need to show the end user what the set of things they can order in order for them to buy them. And if in my head, I kind of think this is the difference between writes and reads. For someone just reading information, I'm going to have a lot different set of constraints and patterns used than someone that is writing information. So what does this look like different when we have reads? Oh, there we go. So what about our reads? So in our restaurant, what is the component? What is the feature of that restaurant that really personifies the reads in the system? And for us, that's going to be the menu. The menu is that very tailor-made set of information that its sole purpose and design is to inform the customer and get them to buy something. We want to make sure a couple things. One, we want to make sure that reading the menu is very cheap, so they can very quickly make a decision about what they want to order, and they're not confused or befuddled about how to read the menu and what kind of things are on there. So the audience for this is the customers. And the last key thing here is that the decisions about how that menu came together is not visible to the customers. So they see the end result of this. They don't see, how the sausage was made in order to give them this final product of the menu. But how the menu was made behind the scenes was probably pretty complicated. So me as a business owner, I'm probably using Excel or Access or something like that in order to keep track of like, well, here's all the ingredients I have. Here are my suppliers. Here's the recipes. Here's how long it takes to make things. And all this information needs to come together to figure out how do I come up with a price. So this backend system is really responsible for managing the menu and figure out what that final menu item and cost should be. Contains all the decisions and business rules associated with coming up with that final number. It might have calculations and forecasts to figure out pork futures are down, so the McRib is back, that sort of thing. Might also have historical trends to see like this product didn't sell too well, so maybe we want to replace that on menu with something else. Or this, this menu item is really popular during this period of time, so we need to make sure we order enough of that, pumpkin spice for September 15th when pumpkin spice lattes come back in Starbucks. Now, a typical solution that you see in the systems that like the in-tier kind of solutions, they use the exact same data source for the front end as the back end. So the exact same, like the same source of data that the back end is using to manage how to present the information to the front end user is the exact same data source. And the equivalent design to this would be that, in my restaurants, I don't have like a placard that I get to everyone or like something to hand up. I give them the Excel spreadsheet. Like, here's the final menu items. Just go to sheet 14. That's got the final list of things. Just, don't worry about the other sheets. That's, that's my supply chain calculations and stuff like that. Just go to the last one, and that's what you should look at. That's not how the real world works. We don't try to use the same data source to solve two very different problems of customers coming in and needing to read information very quickly versus the back end having to manage the information and manage the business process. Those are just two very, very different characteristics. So we likely want two different solutions for each of these. And the better solution would be to have a different tailor-made structure and boundary for the front end as we do for the back end. So yeah, just take that cylinder and just be like, blip. Now there's two cylinders, or once there was one. But what does that mean in the middle? Like, how do we design the thing on the left versus the thing on the right? And information exists on both sides. So how do we ensure that the thing on the left is up to date from the things on the right? So how does the real world do this? So in the real world, the business owner makes their decisions about the menu and updates their own spreadsheet, their own system about here's the prices and everything in there. Updating the menu now is on a scheduled basis. So on a regular time period, the new menu is going to be updated and sent out to all the different restaurants. Now the restaurants, though, when they receive the new menu, guess what? They can't change it. They can't be like, I don't like that price. I want this price instead. No, more complicated in the real world, right? In the real world, we have regions, and fast food has like franchisees, and the franchisees can decide whether or not to take part. Just ignore all the complication. Just say, once I publish out a menu, the individual owners can't change that. Can't change the menu. In fact, the customers can't change that menu as well, right? They can't. I can't be looking at a menu for a steak restaurant and be like, how about instead of $49 for a steak, it's $4.90? Aha, new price for you. So even though that data is duplicated in these different locations, because it's immutable, the ownership is still preserved. So even though I wrote down your price and put it on a piece of paper and sent the piece of paper over there, that doesn't mean that it's out of my ownership anymore. And in fact, if you come in to place an order and you've changed the price, it'd be like, no, you can't change the price, rejected. So because I own that information, but it just has to be over there instead of right here, the ownership is still preserved. So in this case, we can still use our messaging primitives to be able to notify restaurants that the pricing has changed. So in this case, I'm publishing a message to say, hey, everybody, menu's been updated. This is the date in which the menu should be live. So I could actually publish that message ahead of time and make sure it's been received by all the different restaurants. And then on that, I can describe here are the items and their new prices. Now each restaurant will have its own subscription and its own copy of that information. You think about in terms of the business owner sending this out via email, it's got a list of all the different stores and their email addresses, and it keeps track of that list internally. I make sure that it's a durable format, because if I just yell out the new prices to people, I just call them on the phone like, hey Bob, guess what? Price is this today, and then hang up. Like, they could forget that. They could forget to write it down. So I want to make sure that they actually can get this information and go back to it as they need to. And last critical piece here is that each subscriber has its own individual copy of the message. So with each durable message sent to subscribers, each subscriber is now completely unaware of each other. In fact, if we use like BCC and email, they're wholly unaware of each other. But also, I'm not controlling the order or the timing of which each of those subscribers receives and processes the message. So if I've got one store on the East Coast, one store on the West Coast, well, the store on the East Coast may get their message at 9 a.m. Eastern time, but the West Coast wake up late, maybe it's 10 a.m. Western Pacific time. So that's a good 4-hour difference between when those messages are open. And so I'm not, because I'm doing this as a durable message asynchronously, I'm not having to call people on the phone all those different times of the day to tell them the new prices. Instead, me as a publisher can send one email at one time and not really have any coupling from my communication about when exactly the other folks are coming online and reading my message. Now, if one store is closed, the other menus continue to be updated. So if like one of the emails bounces and comes back, the email still got delivered to the other locations just fine, because each of those other stores has their own individual copy of the subscribe message. So some parting thoughts here. The constraints of the real world haven't changed. The latency is just much shorter, but it's not zero. That's one of the fallacies with distributed computing, is that latency is zero, but it's not zero. The timings have gotten much, much smaller, but they still are there. The solutions from the real world about how we organize work and communicate in the real world can also apply directly to our distributed world. The patterns and practices we talked about today, none of these are new terms and new words. These are all things that were figured out decades, centuries, millennia before us. Really what we're doing is recognizing here's how the real world has dealt with uncertainty, dealt with communication problems, but still be able to provide a service to their customers. And because the real world has solved this distribution problem, like, for the most part, besides like ego, I guess, and emotion, then we can address those same kinds of problems with similar solutions using messaging and for more complex interactions with conversation and coordination patterns. And so can you. So thank you all very much. This was effective microservice communication and conversation patterns. I'll be hanging out over here on the chat session to answer questions. Otherwise, thanks for coming. I hope you all have a great rest of the day.